Okay, now that we have looked at the concept of inverse variation, let's use it. Let's look at example 2, use inverse variation. In an inverse variation, x equals 10 when y is equal to 3. Write an equation to represent the inverse variation. Then find the value of y when x is equal to -6. So, we know that there is an inverse variation. So, if we know that there is a k that is equal to the product of x and y. So if we multiply x and y, which we know the values of right now, so 10 times 3 would be k, 30. So write an equation to represent the inverse variation. So your equation could be represented as y equals k over x. So you may have seen an equation where y is equal to kx, where k represents the concept of proportionality. It's just a different concept. This is when we have an inverse variation. So when we have an inverse relationship, then we have a variable, a constant k, where the inverse relationship, when y is not directly proportional to x, which means y is equal to k over x, there is a k that represents this inverse relationship. So once we figure out k by multiplying x and y when both of the values are known, then we can plug it into this inverse relationship, y equals k over x, and and write the equation as y is equal to 30 over x. So now, using this equation, you can figure out any values of y or x when the other value is known. So when x is equal to -6, you can just plug it into this equation. For x is equal to -6, 30 divided by -6 is -5, so we have y is equal to -5. Yeah, so when x is equal to -6, y is equal to -5, using the equation y equals 30 over x. All right, let's look at try number 2. Pause the video, see if you can do it by yourself in this new inverse variation. Write the equation and figure out the value of y when x is equal to 15. Okay, are you ready? So just like we did in example 2, you're going to figure out the value of k by multiplying x and y, which is equal to 6 times 1/2, which means 6 divided by 2, which is 3. So k is 3. Using our equation, we can write that the equation is y equals 3 over x. And now, what is the value of y when x is equal to 15? So using this equation, you can substitute 15 into x. 3 divided by 15 is 3 over 15. If you simplify that, y is equal to 1 over 5 when x is equal to 15. Check your answers, see if you got it right. It shouldn't be too hard. Just follow the relationship, the inverse relationship, in the right way. Just remember that your variables are not directly proportional, they're inverse variation. So y is equal to k over x instead of kx. Let's look at the next example. Application. Use an inverse variation model. On a guitar, the string length S varies inversely with the frequency F of its vibrations. So, if you look at this guitar, a capo is a clamp that effectively shortens the strings on a guitar. So the full thing has a frequency of 329.63 cycles per second. But from, until the capo, we don't know how much cycles per second it is. But the frequency of a 26-inch E string is this. It's a full string. If we know that it has an inverse relationship, it varies inversely with the frequency f. So the string length s and the frequency are varying inversely. So they have an inverse relationship. So you can write the equation as s equals k over f. Or f is equal to k over s, it doesn't matter, but they have an inverse variation. So using this, figure out the data that you know. So 329.63 is the frequency, so for 26 inches, right, for length. So you can plug in 26 into s. So this is the string length when the frequency is this. Okay, so when s is 26, f is 329.63, so you can plug in at the same time to figure out k. You multiply them and you'll get 8,570.38 as the value of k. So now, after solving for k, you can write an equation for the inverse variation where s is equal to 8,570.38 over f. Looking at this, we can figure out the frequency for the new length. The string length is 13 inches when we have a capo. So you can plug in 13 into s. Remember, this is not a frequency. This is a string length. So 13 goes into s, and then you need to figure out f, which is 13 divided by 8,570.38 divided by 13. So that is 659.26. And so the frequency of the 13-inch string here would be 659.26 cycles per second. Good. Let's look at try number 3. The amount of time it takes for an ice cube to melt varies inversely to the air temperature in degrees. At 20 degrees Celsius, the ice will melt in 20 minutes. How long will it take the ice to melt if the temperature is 30 degrees Celsius? So see if you can figure out the two variables, write an equation and figure out the answer by using the equation that you figured out. So pause the video, see if you can solve it by yourself, come back when you're ready for answers. Okay, are you ready? So first of all, you have to write an equation in terms of the air temperature and the time, right? So the temperature in degrees, let's say T, is inversely related. So K over the time, let's say minutes. Yeah. So they're both temperature and time. So let's not use T. I'm going to use C for Celsius is equal to K over minutes per, for time. And then we know that at 20 Celsius, the ice will melt in 20 minutes. So K is equal to 20 times 20, which is 400. Yeah, so your equation could be C is equal to 400 over M. And so now we have the equation, we can figure out how long, the time it'll take the ice to melt when the temperature is 30 degrees Celsius. So when it's 30 degrees Celsius, you can solve for m. M is equal to 400 divided by 30. And that is about 13.33333 minutes. So we can say about 13.3 minutes. Okay, so check your answers, see if you got it right. If you did, good job. That was example 3 using an inverse variation model. We'll continue with the next example in the next video.